Okay, this is part 2 of day 4. And now we're going to talk about our three-dimensional figures here. So we're talking about lateral surface area and volume. And so I have 3 different things I can change. And we're going to take the height. This is going to be the height. This is going to be the length. And this is going to be the width. So in each one of these, here's my original ones. I'm going to put those numbers in. The height is 2. And then go ahead and figure out what the perimeter is. 2 times 3 plus 2 times 1. I get the perimeter is 8. And the area of the bottom is 3 times 1 is 3. So you're going to have to calculate this for each one of these. Pause the video, go ahead and calculate these, and then write them down. Now that I have these, I wrote down my formula for surface area and volume. Now you can go ahead and figure these out based on the numbers we have here. Pause the video, figure those out, and check to make sure you get them right. Okay, now that we have our whole table figured out, we can look for what patterns we have. What if I change just one dimension? That's like right here where I change one dimension. And here I'm tripling each one of these, so I'm still working with a factor of 3 on all these. So if I look at surface area, 22 and 54, that's not proportional. Or 22 and 138, that's not proportional. We don't have any shortcut to those. If I needed to figure that out, I just have to calculate the differences. But if I change all 3 dimensions and I do these two, 178 divided by 22 gives me 9. That's the same as 3 squared. So it's like our factor squared. If you think that surface area is an area, so if I change all the factors, I'm doing area squared, just like areas and yards squared. I get this formula here, factor squared. Now for volume, what's the factor between 6 and 18? Well, that's 3. 54 divided by 6 is 9. And if you divide 162 by 3, that's 27. So 9 is 3 squared, and 27 is 3 cubed. So for volume, these are the ones that work out really nicely. If I just change 1, it's the same as the factor. If I change 2, that's the factor squared. And if I change all 3, it's the factor cubed. Do notice here that I said this is also true for pyramids. And on the other side, I said here, hence this is also true for triangles and parallelograms. And we'll look at what else we have here on these other ones. We didn't do all these little analysis for all the shapes. I'm just telling you it's also true for pyramids. If we change all 3 dimensions here, it's still factor cubed. Alright, so let's look at cylinders here, because again, these are slightly different because I just have a radius and a height. So go through and calculate each of these for the table and figure out surface area and volume. Once we have these filled in, now we need to just figure out, is there a relationship? 24 and 56? There's no relationship there because that's not proportional. And the same thing with 24 and 120. These are not an even factor. But what about 24 and 216? 216 divided by 24 gives us 9. So that's the factor squared. And then on volume, this is times 3, this is times 9, and this is times 27. So once again, if I change the height, it's times 3. So that's the same as the factor. If I change the radius, that's the same as the factor squared. And if I change the height and the radius, I get factor cubed. An easy kind of way to remember this is if I change the radius, this is kind of like doing length and width because I'm changing it in this direction and this direction because the radius goes both ways. That's why it's factor squared. I put a note here that this is also true for cones. Now spheres are slightly different, and I'm just going to give you the formulas for it. If you think about in a sphere, the radius goes in all 3 directions because it goes this way, it goes up and down, and it comes out of the page. So this is the same as this one here, factor squared, and this is the same as the last one there, factor squared, because the radius literally goes in all 3 dimensions. So how do we actually use this information? Well, what you have to remember is these little formulas here, whether it's factor cubed or factor squared. And that's going to be our change that we're going to plug into these formulas. And then all we do is we take whatever we're talking about, like area. My new area is the old area times the change that we had, like factor squared. Surface area new is surface area old times the change. I did put a note here, perimeter and surface area only work with these formulas here if they're proportional. Remember the ones we wrote not proportional? Those don't work with these little formulas. You have to calculate them separate. But for the other ones, they'll work like this. So let's do a couple. Okay, so in this problem it says the length times width times height of a rectangular prism are multiplied by a scale factor of 4. So there's our factor that we're going to use. What is the effect on the volume of the prism? So the volume formula says, here's my changes that I could have. How many dimensions am I changing? Well, I'm changing length, width, and height. So I'm changing 3 dimensions. So that means it's going to be, the change is the factor cubed. So, and my factor in this problem is a factor of 4. So it's going to be 4 cubed gives me 64. The new volume is 64 times bigger than the old volume. The next one says a cylinder has a volume of this. This one they gave me the volume. It has a scale factor of 7 is applied to just the radius. What would the new volume be? Well, I'm going to look at a cylinder. Here's cylinders. And I'm changing the radius of the volume. So it says that it's factor squared here, factor squared. So I take the old volume times the change, which we just said was factor squared right there. So it's the volume old times the factor squared will give us our new volume. But here's my old volume. My factor is 7, and I need to square that. Plug that all in your calculator, and then you get that the new volume is this. That's it. The next one says the volume of a cube is increased by a factor of 1/8. What is the change in the length of the sides? So here they're telling me the volume change. So for a cube, that's like a prism. And the volume change, if I'm changing all the sides, is factor cubed. So here, factor cubed is equal to 1/8. So how do I just find the factor that's affecting one side? Well, this is where I would take the cube root on my calculator, and I find that the factor is 1/2. And finally this one, if the surface area of a cube is 9 times bigger, so here the new surface area is 9 times bigger than the original cube, what will the effect on the volume of the cube be? So here they've got surface area and volume. So surface area of a prism is the factor squared. So the factor squared equals 9. So the factor affecting the cube is just 3. I've just made each side of the cube 3 times bigger. Now what effect does that have on the volume? Well, my volume factor is factor cubed, so I'm now going to take 3 cubed, gives me 27. 27 times bigger than the old volume.